So this video is chapter 4, D-Day number 1. So on this first problem, we're dealing with a normal curve. A lineup for tickets to a local concert had an average mean waiting time of 20 minutes with a standard deviation of 4 minutes. What percentage of the people in line waited for more than 28 minutes? Okay. So my mean is 20 minutes. We want to know what is the percentage of people who've lined up and waited for more than 28 minutes. So let's say this is 28. And so I am looking to get this area really, okay, from 28 to positive infinity. So I am going to do a normal CDF. And I'm going to put in the lower bound first, which is 28, the upper bound, which is infinity, because I want to keep going forever and ever and trying to find that area that I shaded. And then my mean is a 20 and my standard deviation is a 4. And I'm going to put this into my calculator. So let's see. So this is going to be a 28, a 10 raised to the 99, because that's really infinity. 20, oops, 20, and then a 4. And I end up getting a 0.02275. So equals a 0.02275. So if I want the percent, I'm going to move my decimal 2 places, 2.275%, or about 2.28% if I'm going to give 2 numbers after the, well, 4 numbers after the decimal in terms of my original answer. Okay. On number 2, it tested a mean of 85 and a standard deviation of 4. And if Sally scored in the 90th percentile, that means that really she's up here in the top 10. And we want to figure out, and we want to know basically what value here would put her where she is kind of in the top 10%. 90th percentile means that 90% of the people were scoring lower than her. Okay. So when we do this, which is an inverse norm, and we're looking for the value that gave us a particular area, or percent, but a percent is this area. We always are starting from, we're always starting from in negative infinity to that value. Okay. So even if they had asked for what would make her be in the top 10, even if I wanted her in the top 10, which she really is truly in the top 10, I still have to look up the 0.9. Okay, that's what my calculator is going to compute. So I'm going to do inverse norm. And I'm going to put in the area, which is 0.9, the mean, which is 85, and the standard deviation, which is 4. So I am going to put that into my calculator. So let's see. So 0.9, 85, and 4. And I am getting a 90 point, let's say 13. Okay, so my answer is a 90.13. That is the score that she needs to be at to have 90% of the people beneath her. Okay, on number 3, the shaded area of the symmetric diagram represents 95% of the data. Calculate the following. What is the mean? So to figure out this mean, okay, Since this is 95%, we had seen that when we have a standard normal curve, let's say we have a mean of 0, okay, and we go out a -1, we go out 1 deviation, okay? So if I go -1, and here, I'll just put mean. I won't put a particular value here, okay, whatever the mean is. And I go out +1, that this right here would be 68%. That is 68%. 68% about of the data would fall within 1 standard deviation on one side or the other side. If I go out another standard deviation, so I'm going to -2 and 2, this is going to be from here to here. That's going to be 95% of the data. Okay, so that is us going all the way from here to here, 2 deviations on either side. And then if I go out again, 1 more to make it 3 standard deviations, with majority of our data falls within 3 standard deviations. This is going to be about 99% of the data, okay? And so again, that 99% is us going from here all the way to here. Okay, so this situation, when they say we have 95%, we're really going a -2 and a +2 in terms of what a z-score would have been, okay, standard deviation. But in order to find the mean, since this is symmetric, okay, to find the mean, I'm going to take my 78 and my 92, and I'm going to average them. Add them up and divide by 2. So I'm going to actually just put it in a fraction. So I'm going to take 78 plus 92 over 2. And I end up with an 85. Okay. So this is going to equal 85. So that is my mean. What is the standard deviation? So the standard deviation is 2. That's, well, we've gone out 2 standard deviations, but what is the value? So what I know is, I don't care which direction I go. Let's say I take 92 and I subtract 85 from it. That ends up being 7. Okay. So I'm 7 off of my mean. And this is really 2 standard deviations. So if I take that 7 and I split it into 2 equal pieces, each standard deviation is 3.5. 3.5. So if I was to double check myself here, and I was going to take 85 plus 3.5 once, plus 3.5 twice, I should end up at 92, and I do. If I was to take 85 minus 3.5 once, minus 3.5 twice, I should end up at 78, and I do. On number 4, we're going to do a relative frequency distribution. We want the bin widths to be 4, and the minimum score we're looking at is 10. So we're going to start at 10 and be going in intervals of 4. So I am going to make a table here. I'll put score, frequency, and then relative frequency. And they want us to start with a 10 and have a bin width of 4. So it's going to go 10 to 14. Then I'm going to do 14 to 18. I'm just going to keep adding 4. Then I'm going to do 18 to 22. And looking at the data, I think that's going to fit everything in. So I am going to look at 10 to 14, and I'm going to look at all the numbers that are from 10 to 14, but not including 14. 14 would be included in the next section. So looking at this, I have items, okay? Now, if I go from 14 to 18, 18 is not going to be included. So I've got 15, and looks like that's it. So this is going to be one item. And then I'm going to look at 18 to 22. So 18 would be counted there, 19, 21, 20, 18 again, 20. So I've got 1, 2, 3, 4, 5, 6. So I have 6 items. Now, for my relative frequency, I need to know the total. So if I count all those, or if I add this up, in either case, I've got 10. So to find the relative frequency, I really want the percent. Instead of knowing that that happened 3 times, I want to know what percent of the time. So I take 3 and divide it by the total, and I get 0.3. I take 1 and divide it by the total, and I get 0.1 or 10%. Take 6 and divide it by the total, and that's 0.6. So now I am going to put a graph on. I'm going to add a graph on. And I'm actually going to copy this graph real quick because I think I'm going to have some more that I need. So I'm just going to take this, copy it, and I'm just going to paste it down here real quick. Let's move it down. Okay, that's not where I want it, but I'm just going to have an extra copy. Okay. And I'm going to put that here. So for this, I am going to here is my y-axis. This is my x-axis. This is going to be score. This is going to be percent. And I am going to start here with 10, 14, 18, 22. And then going up, let's say I do maybe by 2s. So let me just zoom in a little bit. So I'm going to go 2, it's going to be a 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and so on. Okay. And I need to draw my bar for 10 to 14, which there are 0.3 of them. So I'm going to come up to here. And I'm going to write 0.3. I like to put the number on top so I see it. From 14 to 18, we have 0.1. From 18 to 22, I have 0.6. And there's my relative frequency, okay, distribution. And they said, would a normal curve be good for this? So if I was kind of trying to trace around this, oops, helps if I have a highlighter. That goes down and back up. So this would not be a normal curve because I would want that 0.6 to be in the middle because your mean is always in the middle and it should be a bell-shaped curve. So would this be a good model for a normal distribution? No, because the tallest bar is not in the middle. Okay, and for a bell-shaped curve, it should be in the middle. Okay, on the next problem, okay, I am just going to move that out of the way right now. Okay, so on this particular problem, it says a store produces pants and sports jackets. Each pair of pants needs 1 square meter of cotton. and 2 square meters of polyester. Okay, so let me just, I've got cotton here. Every jacket needs 1.5 square meters of cotton and 1.5 square meters of polyester, and the store has 750 square meters of cotton. So let me just highlight my polyester, 2 square meters of polyester for the pants, 1 for the for the jacket, and 1,000 for the total amount that we have. Then they also give us a little information about profit. Profit is $50 for pants and $40 for jackets. Okay. So the first thing I'm going to do is define my variables. So I'm going to let X equal, and I'm going to put pants first. And so this is number of pants. And Y is going to equal number of jackets. And they want constraints, but I am going to also write an objective function just so you guys see that. So my objective function is what I'm trying to maximize or minimize in this case, which is profit. So my objective function is going to be profit equal, and it is $50 for the pants, which are X, plus $40 for the jacket, so 40Y. So that is my objective function. Then my constraints, and this is what they actually wanted us to do. These are the inequalities. I'm going to have 1 on the cotton and 1 on the polyester. So for the cotton, I've got 1 square meter of cotton for the pants, so that's going to be 1X, plus 1.5 square meters for the jacket, so that's 1Y. And we only have 750 square meters, so it's going to be less than or equal to 750. That's one constraint. The other constraint, polyester. So we have 2 square meters of polyester for the jacket, so 2X, and 1 square meter polyester, so 1Y for the jacket. And we only have 1,000 square meters total, so less than or equal to 1,000. Those are our constraints. Okay, so this, let me just hold on. I'm just going to move this down to these ones down here. Okay. So on this problem, I noticed that we have the square root of 2x plus 1 here and here. So that's what I'm going to let my u equal. So let u equal the square root of 2x plus 1. Then I'm going to rewrite my problem. And so it's going to be 3u squared minus 19u minus 14 equals 0. I'm going to do a box to diamond. So in my box, I'm going to have a 3u squared and a negative 14. And if I take 3 times the negative 14, I'm going to get a negative 42u squared. And it also has to add to a negative 19u. And so for this, let's see, if I do, trying to get a 19. So 42 would be 1 and 42, 2 and 21. So I think it's going to be this 2 and 21. So it's going to be a negative 21u and a positive 2u. Okay. So I'm going to put my positive 2u here just because of spacing. I'll put my negative 21u here. And let's see, on the outside, I'm going to have a 3u and a u times 2 and 3u times a negative 7. So my factors are going to be 3u plus 2 times u minus 7 equals 0. I'm going to solve each of these for u by setting each factor to 0. So u is going to be a negative 2/3 and a 7. So now I need to take these answers and I need to set it equal to this. So I am going to have square root of 2x plus 1 equals a negative 2/3, and a square root can't equal a negative. So this is going to be no. So then I'm also going to take my square root of 2x plus 1 and set equal to 7, which I can do that. That's okay. Square both sides, I get a 2x plus 1 is equal to 49. 2x is equal to 48. I divide by 2, and I end up with a 24 as our answer. So let's see, number 7. Okay, so on this, let me get my graph. Okay. And I'm just going to get all my graphs. Give me a second. All my graphs. So for the graphs, this first one is a cubic graph. And my inflection point is at -3, -5. So I'm going to plot that. First, I'm going to just get my X and Y axis. So, and I'm going to raise it up a little bit. Okay. So my vertex, I mean, not my vertex, but my inflection point is at -3, -5. So I'm going to go -3, 1, 2, 3, 1, 2, 3, 4, 5 here. Okay. Now from here, I'm going to do the rest of them different so we can kind of see that that's where my middle is. If I went out 1 cubed is 1, and there's no stretch in front, so I'm just going to go 1. If I go out 2 cubed is 8. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Okay, if I went the other direction from my inflection point, -1, -1 cubed is -1. And if I went from an inflection point out -2, -2 cubed is -8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to draw my curve. There we go. And that's my graph. On the next one, this is a square root graph. So half of a sideways parabola. My vertex is going to be at 2, 5. Okay, so let me draw that graph in. I'm going to scoot it over this a little bit. Okay, so I am going to start at my 2, 5, 1, 2, 3, 4, 5. Oops, skipped over a little bit, sorry. 2, 5. And then from here, I'm going to take square roots. So if I go out 1, square root of 1 is 1. I'm not going to go 2 because the square root of 2 is not nice. I'm not going to go 3 because the square root of 3 is not nice. But I'm going to go 1, 2, 3, 4 because the square root of 4 is 2. And then I'm going to go 5, 6, 7, 8, 9 because the square root of 9 is 1, 2, 3, and so on. Oops. And then I'm going to connect this. And there's my square root. So on letter C, this one, I can think of a critical point as -3, -4, but this is not actually a point on my graph. I do have an asymptote at y in -4. So let me just get my X and Y axis in. So let's say I start here, I'll move that over slightly. Guess I can move that over, okay. And then I'm going to drop it down a little bit. Okay, and my asymptote's gonna be at y equal -4. So let's say here, let me just drop it down. And let me make it dashed. Okay, so that is my asymptote, and that is y equal -4. So this point that I was talking about earlier, that's -3, -4. So if I went to -1, 2, 3, -1, 2, 3, 4, so I put this point here. That point that I just put there in red is not a point on my graph. It's kind of telling me where I'm going to start my graph. So let's say I do it in green. So from here, this is where I would start and do like 2 to the 0. And 2 to the 0 is 1. And then if I went over 1, that's like 2 to the 1. And 2 to the 1 is 2. And then if I go over 1, 2, that's like 2 squared. And 2 squared is 1, 2, 3, 4. And if I went out 3, that's 2 to the 3rd, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, really, what's happening? This one's going high, and the next one's 2 high. I'm doubling every time because my base is 2, my multiplier is 2, so that's 1 high, double that 2, double that 4, double that 8. The next one's going to be 16. So 9, 10, 11, 12, 13, 14, 15, 16, and so on. And let me draw my graph. And there's my exponential. Okay, the next one is a reciprocal function. And if we are thinking about a locator point, we might be thinking 8, 4. But I do want us to understand that these have a horizontal and a vertical asymptote. The vertical asymptote's at x equal 8. The horizontal asymptote's at y equal 4. Okay. So let me draw that x and y axis in. So I'm gonna be at 8, 4. So maybe I'll push it over a little this way. And here, let me make these black. Okay. Okay, so those are my x and y axis. And I'm going to have an asymptote at y equal 8. So let me count over here. So that's 5, 6, 7, 8. So x equal 8. Oops. Okay. And let me just make this dashed. Okay. So again, this is going to be x equal 8. Then I'm going to have a horizontal one at y equal 4. So that's going to be here. And again, let me make it dashed. Okay. So that is going to be y equal 4. And then if I look and see the top number here is a 1, really I want things that multiply to 1. So when I'm graphing this, what I'm thinking is, okay, if I start at that 8, 4, which is where these two asymptotes meet, and I go out 1 times what gives me 1? 1 times 1. Oops. Oh, I can do that. Okay. So I am going to go to 1, 1. And then if I go backwards, -1 times -1 is 1. So those are going to be the 2 points that I'm just going to graph. Everything else I'm just going to sketch. And so I have a branch here. And I have a branch here. And that's my reciprocal function. Okay, on the next page. Okay, so we have a system of equations. We're going to use equal values. So I'm going to take the square root of -x plus 5 is equal to x minus 5. And what I need to remember is this right here. I need to make sure at the very end to check, because I cannot have the principal root of a square root being a negative. Okay, so I'm going to check my answers. So I am going to have the square root of a -x plus 5 is equal to x minus 5. I am going to undo that by squaring both sides. And when I square the square root, it undoes, and I get a -x plus 5. Now, on the other side, it is a perfect square trinomial. So I end up getting x squared minus 10x plus 25. I'm going to get everything on one side, 0 on the other. So I'm going to add my x to both sides. I'm going to get a -9x. I'm going to minus 5 on both sides. So I get a 20. And then I'm trying to think of what multiplies to a -9, to a positive 20 and adds to a -9. And that's going to be a -5 and a -4. So I'm going to get x is equal to 5 and x is equal to 4. However, remember, I need to take these answers and I need to check them here. And I want to make sure I don't get a negative. So if I put in 5, 5 minus 5 equals 0. So that's okay. So what I just found is that my x-intercept is 5. And when I put 5 in, I ended up getting 0 back. So that's one solution. If I put in a 4, 4 minus 5 is equal to a -1. So that one is not going to work. So I only have one point of intersection at 5, 0. Okay, on 9, I'm going to factor. And from this, I'm going to look and see what can I factor out in terms of numbers. I can factor a 2 from both of them. And in terms of my x's, I can factor out an x to the 3rd. And I'm going to be left with an x to the 4th minus 4. And this is actually a difference of 2 squares. So I still have my 2x to the 3rd, and then that x to the 4th minus 4 is a difference of 2 squares. It's an x squared plus 2 and an x squared minus 2. Now, I always want to look and see if I can factor something. Any of these with the plus, I can't factor, not over anything real. And this I could factor, but 2 is not a perfect square. So that's going to be left. So this one is my final answer. On B, on this one, I can't factor out any numbers, but I can factor out an x, and I get a 6x squared plus 13x minus 5. And so now I'm going to do a box to diamond. And for my box, I have a 6x squared here and a -5, which is going to give me a -30x squared, and it has to add to a 13x. So I have to be careful. It has to add to 13, but it has to multiply -30. You might think 10 and 3, but I need one of them to be positive and one of them to be negative. And so a 10 and 3 would not subtract to get me a 13. So I think it's going to be a 15x and a -2x. 15x and -2x. So this is going to be a 2 and a 3, a +5 and a -1. So my factors are the x that I factored out originally, my 3x minus 1, and my 2x plus 5. On number 10, domain. So depending on what type of situation you have, if it's a square root, you want to make sure you don't have a negative underneath your square root. So you basically want to find your 0, and it's everything that would make it 0 or higher. In this case, if you have a denominator, you can't have your denominator 0. So what would make that 0? A positive 5. So that means everything but 5. So I'm going to write negative infinity up to 5. Okay, I've got parentheses because both of them are open bracket. Union 5 to infinity. And that basically means everything but 5. On 11, okay, we're going to be graphing these. The top one is a absolute value. It's a V shape, so it's -3, 2. So I am going to go to -3, 2. And this absolute value has a stretch of -2/3. So since a absolute value is linear in nature, that a stretch is really like a slope. So I'm going to go down 2 and out 1, 2, 3. And I'm going to go out down 2 and out 1, 2, 3. And draw my line. And I want it to be less than or equal to, so it is solid because it's less than or equal to, and I would be shading below. The other one is going to have a vertex at -1, -4. So I'm going to go to -1, -4. And then this is a parabola, and there's no stretch in front. So that means I'm just graphing like from here, a regular parabola. If I go out 1 squared is 1 on both sides. If I go out 2 squared is 4. 1, 2, 3, 4. And I don't know why this one's here. Oops, that was a mistake. If I go out 3, 1, 2, 3, 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to do the same on the other side. Now this parabola is a dashed curve. So I'm going to draw a dashed curve. And we want to shade greater than or equal to. So I want to shade above my parabola, but under my absolute value. So this is where my shading is going to be. On number 12, okay, we're solving absolute value. First thing I'm going to do is I'm going to minus a 2. So I get 12x minus 9. I'm going to divide by 3. And I get 4x minus 3. And when I have my absolute value isolated, this is where I'm going to check my answers to make sure, to make sure that I'm getting a positive value there, not a negative value. So I'm going to have x minus 2 equals 4x minus 3, and x minus 2 equals a negative 4x plus 3. You make both of the terms on the other side opposite. So I'm going to minus x from both sides on the first one. I'm going to add 3 to both sides, and I get a 1/3 as an answer. And I need to check that here in a second. I'm going to add 4 to both sides, so I get 5x. I'm going to add 2 to both sides, so I get 5x equals 5. I'm going to divide by 5, and I get x equal 1. So remember, I need to take this and this, and I need to check it here to make sure I don't get a negative. So when I put in a 1/3, 4, start again, times 1/3 minus 3. Okay. So 4 times 1/3 minus 3. I end up with a negative 5/3, which means that this one cannot be an answer. Then I'm going to go 4 times 1 minus 3, and that I get a positive 1, so this one's going to be okay. On B, you want to make sure that you get a common common base for both sides. That's going to be 3, so I'm going to have 3 to the 2x plus 5 equals, and 27 is a 3 to the third. Then what has to happen is this exponent and this exponent have to be the same in order for these to be equivalent. So I'm going to take 2x plus 5 and set equal to 3 so I can figure out what x has to be. I'm going to minus 5, so I get a negative 2. I'm going to divide by 2, so I get a negative 1. Okay, letter D, inequality. So I am going to get everything on one side. So I'm going to minus my 60, which is going to give me a negative 63. So basically, that's the inequality I want to solve and shade. But let me set equal to 0 to figure out what my boundary points are. So what multiplies to negative 63 and adds to a 2, a 9, and a negative 7? So I'm going to get x is equal to negative 9 and x is equal to 7. And so I'll have my number line. And I'm going to be putting on a negative 9 and a 7. And when I look back here and I see that this is strictly less than, so that means that these are going to be open circles. And then I need to decide where to shade. So I think about this as a parabola, and I want a parabola. I want where the parabola is less than 0. So basically, if 9, negative 9, 7 are my x-intercepts, I want where it's below those, below the line, the number line. So this, I'm above, I'm at 0, below 0, at 0, above 0. So where I am going to shade is I'm going to shade, since I want less than or equal to, everything here. And so my answer is going to be negative 9, less than x, less than 7. Okay, on E, this is isolated. So I'm really going to solve 4x minus 3 equals 21 and 4x minus 3 equals a negative 21. I'm going to add 3 to both sides. So I get a 24, divide by 4, and I get a 6. For the other one, I'm going to add 3 to both sides, and I get a negative 18. I divide, right, because I'm adding 3. Yeah, I'm dividing by a 4, so I get a negative 18 over 4, or negative 9 halves if I reduce, or a negative 4.5. So for this, I'm going to have a negative 4.5, let's say, and 6. If I look back at the original problem, I want it to be greater than or equal to. So that means solid circle, solid circle. And then if I'm thinking of an absolute value, which is a V, I want, where is it greater than this value? Greater than, if this is at a height of 21. So above, 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 at, below, below, still below, below, at, above, above. So I am going to be shading everything on the outside. And then my answer is going to be x is less than or equal to negative 4.5, or x is greater than or equal to 6. On number 12, this with an x squared and a y squared is going to be a circle. So I'm trying to get it to look like this: x minus h squared plus y minus k squared equals some number, which is really your radius squared. So I'm going to get my x's together, leave myself some space. I am going to get my y's together. So y squared plus 2y, leave myself a blank, equals, and I'm going to take the 4 to the other side. So I got 4. Then what I want to do is I want to ask myself, okay, what is half of negative 12? And half of negative 12 is a negative 6, and negative 6 squared is 36. So I'm going to add 36 to both sides. Then I'm going to look here and say, okay, what's half of the 2y? And so I'm taking 2, dividing by 2, which is 1, and then squaring. So this is going to be a plus 1 and a plus 1. So I'm going to get x minus 6 squared plus y plus 1 squared equals 41. And that's my answer. So finding x and y intercepts. So let's say I do y intercepts first. That's kind of the easier one. So I am going to put 0 in for y. I'm sorry, in for x. So when I put 0 in for x, the only letter I have left is my y. So I'm going to get y is equal to 0. That is a y-intercept. Now, when I'm doing the x-intercept, I'm going to put 0 in for y, and I need to solve. So I'm going to divide everything by 2. I'm going to factor out an x. What makes this 0 is x equals 0, so that's an x-intercept, which makes sense if I have 1 at y equals 0. So 0, 0 would be my x and y-intercept. And then I also have it at x equals 3. And that's the end of this video.